that the substances which actually get oxidized are reducing agents, okay, and the substance which get reduced are oxidizing agents. That's what we have discussed, okay. We were about to discuss a new definition for oxidation and reduction, that is in terms of electrons, okay. And I told you the mnemonic oil rig, okay. Oil rig is it means oxidation. Is loss of electrons. While reduction is gain of electrons. Got it?
Yes, sir.
So for example, if we are looking at this reaction, so what may have happened? This reaction you might have also seen in your class 10th, okay. So what is actually happening in this?
Transferring of electrons.
The transfer of electrons, exactly. So who is losing electron to whom?
Zinc is losing.
Yeah, zinc
Zinc
is
is
losing.
gaining into it.
So zinc, actually, if you remove the electrons, electrons are negatively charged, right? So the two electrons are being transferred from zinc to copper. So basically the zinc is losing electron and the copper is gaining. So that's why the copper become neutral after gaining two electrons. Got it? Is it clear?
Yes, sir. Yeah.
Copper gained electron, its positive charge came down, or the other way to tell it is got reduced. So copper got reduced. Got it? And as I have written, reduction is gain of electrons. Copper has gained two electrons, so it has reduced. And zinc has lost electrons, so zinc is oxidized. I hope this is clear to you.
Yes, sir. Yes, sir.
Okay. So the one who get reduced is an oxidizing agent. And one who get oxidized is a reducing agent. Got it?
Yeah. Yes, sir.
So there are multiple examples related to these type of reaction, but every time this was very easy to know that the copper has gained electrons and it has reduced because the 2 plus charge was there. I have not written any other in any other form in any other type of compound. I have directly given you copper 2 plus. Got it? So
Yes,
that's
sir.
why we were able to figure out clearly that this copper has gained electrons. But sometimes it may become difficult because nobody may give you the ions like this. Simple ions, cations like this, where by which you can make out easily who got reduced and who got oxidized, right? You will maybe getting some compounds. In those compounds, it may be very difficult to know who got reduced and who got oxidized. Got it?
Yeah.
So there is some other method also which is more general. For example, if I ask you who got reduced, who got oxidized in so this sometimes it become very difficult to know which is the oxidizing agent, which is the reducing agent, and which substance got reduced and who got oxidized. Like in this case. So I will tell you a more general way to make out the
Over here, isn't H2O2 getting oxidized?
H2O2 got reduced actually. Got it.
But it's
So
gaining potassium.
yeah, it's gaining potassium exactly. Yes. So more electropositive element. Okay, so and it is gaining electron also. But it is not like the above question where you can clearly make out that like the copper has gained 2 electrons, so here you gain 2. The H2O2 has gained electron because it is a compound, not an ion. So let me introduce you to a new method, that is oxidation number method. It's a more general method which can be applied at all the places. Okay, so you should not look for oxygen, whether the oxygen are being added or removed, hydrogen are being added or removed, or electrons are being added or removed. Okay, a more general method is to go through oxidation number method to know whether an element or a compound got oxidized or reduced. Okay, so first of all, let me tell you what is oxidation number. So what is oxidation number? Tell me.
Is it like maximum or minimum number of electrons that can be
Yeah, it is
recorded?
the charge that would appear on an atom in a molecule on the basis of electronegativity of its substituent. So on the basis of electronegativity, you try to find out the oxidation number. Okay, I will tell you the rules. And by this oxidation number, whether it has increased or decreased, you can make out whether the oxidation has happened or reduction has happened. So this is a more general way. Instead of comparing addition of oxygen, removal of oxygen, addition of chlorine, addition of hydrogen, removal of sodium, removal of potassium.
So what exactly is electronegativity?
Yeah, that also I'm telling you. Basically, you know, in a periodic table, you have metals and non-metals. Okay, and some elements are metalloids. This is the periodic table. And there are certain metals which have tendency to accept electrons even after they get bonded. Even after they bonded, they try to pull the bonded electron toward themselves. And this tendency is known as electronegativity. It is basically the tendency to accept the bonded electron, pull the bonded electron towards themselves. Okay, most of the non-metals on the right hand side of the periodic table are electronegative, and they have tendency to pull electron because they want to become minus. Suppose if you have Cl atom, right? So what do you think? H and Cl. HCl is a covalent molecule, right?
Yeah.
How? So this is a bonded electron pair. How will you think that this bonded electron pair is going to get shifted? If you are asked to break this bond, should I break it like this? H minus and Cl plus, or Nabila, should I break it like this? H plus and Cl minus. This you understood these two dots. What are these two dots? These are the electrons. So
Okay.
you assume, so you will try to think that who took away the electrons. The answer is very simple. The one who is more electronegative, the one who is more on the right hand side, that is more electronegative. Electronegativity is like this. Got it?
Yeah.
So fluorine, oxygen, nitrogen, chlorine, these are the four most electronegative elements. Okay, they have tendency to pull electrons. Why they have tendency to pull electron? Because they are on the right hand side of the periodic table, they are non-metal. You already studied in class 10 that metals were electropositive and the non-metals are electronegative. Metals were having a tendency to lose electrons. Non-metals were having tendency to gain electron. That you might
Yeah.
have studied in your class 10th. Okay. Same thing we are going to put here. So if you have a bond on the basis of electronegativity, you will consider the charge on an atom. Got it? And on the basis of the charge, that charge actually is oxidation number. So you will try to figure out what is the oxidation number, and on the basis of that oxidation number and the change which it undergoes, you will try to figure out whether the oxidation has happened or reduction has happened. Is it clear? So Cl is a non-metal, more towards the right hand side of the periodic table, more electronegative. So I will consider it this way, not this way. Okay. And when you break HCl and water, that's how it happens. H plus and Cl minus. Okay. So what is the oxidation number of Cl? -1. What is the oxidation number? +1. Got it?
Yes.
I will be telling all the rules, but this is just the basic idea of oxidation number. So it is the charge that would appear on an atom in a molecule, okay, on the basis of electronegativity of the bonded substituents. Okay, why we are interested in oxidation number? What's the use? We want to find how the oxidation number has changed. We want to know whether the oxidation number has gone up or gone down. By that, we will try to figure out that the substance has gone oxidation or reduction. Got it?
Yeah.
So let me write the rules for oxidation number. Rules to find out the oxidation number. These some of the rules are very simple, and you are very much aware. Not directly, indirectly, you are aware of this method. Okay, let me put it in a more formal way. Rules to find the oxidation number. How will you find the oxidation number? Though I told you a general idea to find oxidation number in HCl, same thing you are going to follow, but I will be telling you a more detailed method. Okay. Rule number one: oxidation number of an element in its elemental form is zero. Why?
Second LP.
Oxidation number of an element in its elemental form, it is the form in which the element exists. Okay.
It
In
can
which
be
it is not combined
the
to
number
anything.
can only be when it's with combined with another element, right?
Yeah, exactly. Suppose elemental form, if it is pure element like sulfur is exists found in acid, oxygen is found as O2, chlorine is found as Cl2. Got it? Phosphorus is found as, you might have studied atomicity, okay, in class 10th also. So that tells us how many atoms are there in it, right? So in a molecule of an element. So basically, sulfur is connected to which other element? It is connected to sulfur only. So who is more electronegative? That question now is not valid because all are same, all have same electronegativity, all are same atoms. Okay. So what charge should I consider? Zero. Navila, is it clear or not?
Yes, sir.
Zero, zero, zero. Got it? So if you have an elemental form where the element atom is not connected to any other substituent, the oxidation number is going to be zero. Point number two. This is quite simple. I hope any doubts in this, Maha, Nabila?
No, sir.
Oh, great. Clear? Now the second point. That also is very simple. In case of a monatomic ion means you do not have multiple atoms, just one single atom in an ion. So whatever the charge is there, that is the charge of that atom only. Okay, and it is the oxidation state of that particular element, okay, present in that ion. Okay, so in case of monoatomic ions, the oxidation number of monoatomic, okay, I'm underlining this, means there is no other atom. So oxidation number of the will be equal to its charge. For example, What is the oxidation number? So you don't have to consider the electronegativity and all, because you do not have any two elements, just one element, and whatever the charge is there, that is the charge of that particular element only, and that is the oxidation number.
Okay, sir.
So oxidation number of Na is +1. This is +2. This is +3. This is -1. This is -2. Oxygen is -2. So this is -2. Got it? Any
Yes,
doubts
sir.
in this? Clear?
Yes,
Very
clear.
But so till now we were handling these situations, okay, and but now the oxidation number is actually used for more complicated situations where you can't directly figure out whether the oxidation has happened or reduction has happened. So in case of polyatomic anions, so that is where it is more important, and that is where its importance is, okay. So in case of polyatomic anion, means it is a group of atoms and there is a charge on that group of atoms. So sum of the oxidation numbers of all the elements in that anion will be equal to the total charge. Okay, if you are just one atom, whatever the charge, that belongs to that atom only. Okay, and that is the oxidation number of that atom. But if you have many multiple group of atoms and a charge, so that charge is not of any particular, that charge belong to the whole polyatomic anion. So there the sum of the oxidation numbers, algebraic sum of the oxidation numbers will be equal to the total charge of the polyatomic anion. I hope you are getting my point. I will write it. After that it will be more clear. Got it?
Okay, sir.
Sum of the oxidation numbers of in I should write polyatomic ions. So in case of polyatomic anions or molecules, the sum of the oxidation numbers of all the elements will be equal to the total charge of the polyatomic ion, or in case of molecule that total charge is 0. That's why it is considered as molecule. Okay, so let me uh, take examples. This is very simple, and this actually rules will help you to find the oxidation number of an unknown element. For example, if you take CCl4, What is the total charge on CCl4? What is the total charge? Have I written any plus or minus? Maha,
No.
Nabila? I have
No.
not written any plus or minus. Okay, means the total charge is 0. Sum of the oxidation numbers of all the elements means there are 4 chlorine atom and 1 carbon atom. If you combine the oxidation number, their oxidation number, sum of these oxidation numbers should be equal to 0. Got it? And that's what I have written. Polyatomic anions or the molecules, sum of the oxidation number equal to the total charge. In case of molecule, the total charge is 0. Got it? So, how can we do it? Suppose if you are asked to find out and how can we use this rule to find out the oxidation number of any unknown element? So suppose in CCl4, if I ask you what is the oxidation number of carbon? So what you will do? You will assume it to be X.
Okay.
What is the oxidation number of Cl? Will you assume? This rule is valid only, can be used only if one of the oxidation number is not known and the others are known. So if you take the algebraic sum, you can put that algebraic sum equal to the total charge, and with that you can find out, you can solve it, the equation for the oxidation number of unknown element. Got it?
Yeah.
Is it clear? So suppose if I ask you what is the oxidation number of carbon, so let it be X. Okay. What is the oxidation number of Cl?
Cl
Cl
-1.
-1, because we have seen it at many places. It is the electronegative element. Okay, yes, exactly. Cl is -1, NaCl you have seen. Okay, it is more electronegative, so Cl is -1. Okay, correct. So -1. How many times you have -1? 4 times. Okay, and this is the sum of the oxidation numbers of 4 chlorine and 1 carbon, and it will be equal to 0. So what is the oxidation number of the carbon? +4. Got the point?
Yes, sir.
Yeah.
So very simple. Suppose if I ask you what is the oxidation number of sulfur in SF6? Oxidation number of sulfur in SF6. So who is more electronegative?
F6.
This is the decreasing electronegativity order. The mnemonic is Fonsel-Bressy. Okay, Fonsel-Bressy, FONCL. There are values also. Okay, electronegativity of
So we have to solve this like we did for ClCl4.
its order is, this is the order of electronegativity. Okay, got it? Decreasing electronegativity. So chlorine is more electronegative or sulfur is more electronegative?
Chlorine.
Yeah, F is more electronegative. So what charge should we consider? -1, because the chlorine is more electronegative. Okay, sulfur, I have asked you what is the oxidation number of sulfur. Let it be X. There are 6 fluorine atoms, each having -1 charge equal to 0. This is +6. Got it?
No, for S, previously you wrote it as -2, correct?
Pardon?
The oxidation number for X, S.
For this sulfur?
Yeah, we wrote -2.
No, it is not -2 because I have asked you what is the oxidation state of sulfur. Okay, oxidation number of sulfur. So you know that it is connected to fluorine, which is more electronegative.
Yes, sir.
And fluorine, just like chlorine, is -1. Okay, so -1, -1, -1, 6 times. And what should be the sum of the total charges on this SF6? That should be 0 because there is no charge appearing on SF6. Do you agree with it or not? It is a neutral molecule. So sum of the total oxidation number should be equal to the total charge, that is 0. Sulfur, if it is asked, I will assume it to be X. And fluorine being more electronegative, I will give negative charge. More electronegative will pull the electron and that will have negative charge on it.
Okay.
-1 on 6 fluorine, so it will be -6, and sulfur I assume to be X. Got it?
Okay, sir.
So what is the charge on sulfur? It is +6. Okay.
Okay, sir.
So that's how I'm going to use this rule. So in the case of polyatomic ions or molecule, the sum of the oxidation numbers of all the elements, okay, should be equal to the total charge. Okay. So we will be using it again. Maha, is it clear? This point?
Yeah.
So we will be using it again. Let me talk more about the oxidation number of oxygen and hydrogen. Oxidation number of oxygen. Normally, oxygen is a very common element, and it is the element which actually let us decide who is getting oxidized or reduced. Very, very important. So we need to know what is the oxidation number of oxygen. What is the charge we should assume on oxygen? Okay. So the next rule is about the oxidation number of oxygen. It is 0 in elemental form. That already I covered in previous point that in elemental form it is 0. It is normally oxygen carries what charge? Can you tell me? What charge is carried by oxygen?
Negative.
Yeah, negative. What? How much negative?
-2.
-2 exactly. Why -2? Why not? Normally, I'm asking. Why not -3? That's correct.
Because usually oxygen in the form of O2, right?
Mm-hmm. Yeah, O2. It is -2. That is also correct. So somewhere at the back of the mind, you have the idea. Okay, but you might have not formally gone through this definition. Okay, we are doing it here now is so you have idea. So we are putting it in more formal way, detailed way with explanations and definitions. Okay. So in oxides, the oxidation number of oxygen is taken as -2. That is correct, because by the normal molecules with oxygen form oxides, you can see it is -2. There is one more point. What, suppose oxide ion, if oxygen atom is having how many electrons? Okay, total 8 electrons. So when it react, it will try to gain electrons. It will gain 2 more electrons so that its octet become complete. Got it?
Yes, sir.
So that's why, so that you already know. So that is why the oxygen in oxides carries -2 charge, not -3. Okay, because normally while reaction, there is a give and take of electrons. So oxygen actually accepts 2 electrons and it forms an oxide ion. And oxygen is more electronegative, that we know. So oxidation number of oxygen in O2 where it is not combined with anyone else is 0. In case of oxides, it is -2. That you already know. But you have to be careful. It is not always -2. Okay. I will first give you the, for the example of this, like carbon dioxide. Okay. What is the oxidation number of carbon? How we
We'll
will try
take it
to figure out?
as extra.
Yeah, take it as X. Correct. What is the oxidation number of oxygen?
So the atomic number,
Mhm.
sorry, oxidation number of carbon will be 2.
-2. Yeah, -2. Okay. So there are 2 oxygen atoms, each is having -2. What is the total charge? 0. X is equal to +4. Got it?
Yeah.
Yes, yes, sir.
Okay. So oxidation number of oxygen is -2 in case of oxides, that you already knew, but we are putting it in as a rule. Okay. Like what is the oxidation number of sulfur in SO2 and SO3? What is the oxidation number of nitrogen in N2O5? Just calculate and tell me in your rough work, in your notebook, just calculate. Take it as X. For sulfur and nitrogen, you have to tell me. I hope you got the idea of what I'm
Yes,
trying to ask, and how you are going to use the oxidation number of oxygen to find the oxidation number of sulfur and nitrogen. Got it?
sir. X is 4.
Yeah, this is +4. Exactly. Because
SO3
my,
will be
yeah,
6.
yeah, +6, exactly. For nitrogen, it will be
Is it +5?
yes, exactly, +5. So this is the oxidation number, oxidation state of nitrogen. Okay, 2x minus 10 equal to 0, x equal to +5. Got it?
Yes, sir.
So most of the oxides, what you have to find out the oxidation number of the underlying atom.
We can't take it as equal to 0, right?
Yeah, in this case, because these are polyatomic ion, the sum of the oxidation number must be taken equal to the total charge. Which sign you need to take? Okay, +2 or -2, whatever the sign is. Got it?
Yes, sir.
So for the first one, I have to take it as equal to -2.
Yeah, equal to -2. So you need to find the oxidation number of the underlined element
First one
by
is
using
6.
Yes, sir.
This is +6, right? Correct.
And
This
plus
is
7.
+7, absolutely correct. Sulfur is
Also 6.
yes, +6. Phosphorus, I am asking for other element because oxygen we are taking it as -2.
Five.
Phosphorus is +5, right?
Yeah, 5.
Correct. Chlorine,
7.
yes, +7. And what about the oxidation number of chlorine in the last molecule?
One.
It is +1, yes. So as you have seen that the chlorine can have, so these are not the monoatomic ions first of all. Okay, there the charge was clearly visible to you. And whatever the charge was there, that was their oxidation states. For example, in case of S2 minus sulfide ion, what is the oxidation number? Needless to ask, it is -2.
Yes, sir.
Got it? So, uh, in but every time you will not be having a monoatomic anion or a cation, you may be having polyatomic ions. So there, uh, whether the element has gone oxidation or reduction, that means in order to get that, in order to clarify, you need to know the oxidation number. Okay, you need to find the oxidation number, and that's why we need to know these rules. Okay, so oxidation number of oxygen in most cases is -2, but not always. You should be careful about it. I'm writing another point, but this is not a common point. Okay, so oxidation number of oxygen in peroxides is -1. Oxidation number of oxygen These are some
So
exceptions.
what's peroxides?
Yeah, peroxides. Have you heard of any peroxide? The most common peroxide is hydrogen peroxide, H2O2. Okay. Hydrogen is +1. I will tell the point about the hydrogen also. Like we are discussing for oxygen, next point will be the hydrogen. Hydrogen normally it is taken as +1 with electronegative element. So +1, +1, got it? And there are two oxygen, 2x equal to 0. So x is equal to -1. Peroxides are plus Na2O2.
Okay.
This is more easy because Na is +1. Okay. That also I will write as a point. So sodium is +1, that you know already. So 2 sodium means +1 +1 +2 charge. What is the charge on O2? Collectively it is -2. -2 on 2 oxygen atoms. So what is the charge on 1 oxygen? -1. I hope this is clear. Got it?
Okay.
Yes,
This
sir.
is -1, and so peroxides it is -1. Peroxides, let me tell you one more important thing. They have OO linkage. Got it? But most
What's
common is
that?
this OO linkage. Oxygen-oxygen bond linkage is there in peroxides.
Okay.
So if you are given the compound which has oxygen-oxygen linkage, it is a peroxide type of. Got it?
So O2 is an peroxide too.
No, O2 is O double bond O. O2 is not peroxide. O single bond O. Because O2
So
is
if
not.
O2 is in form with another component has the power of like 2, then it means it's a peroxide.
Yeah, if it is connected to some other elements where it is having a single bond, oxygen single bond is there, then it will become peroxide. Got it?
Yeah.
Oxidation number of oxygen in OF2. This is again an exception. And O2F2. These exceptions are not commonly found. So if it is asked commonly to take the oxidation number of oxygen, you will take it as -2 only, as we have done in above cases. But in some cases, you will have these kind of situations. Okay, is it clear?
Yeah.
What about
Yes.
OF2 and O2F2? Can you tell me OF2 and O2F2? Just think of the electronegativity. Electronegativity. Who was more electronegative?
I mean OF2 the O will be -2, while in O2 it will be -1.
It will be -2 or -2 or what? So based on the electronegativity, we should give the allot the charges. Okay, the one who is more electronegative will take the charge, negative charge. Okay, and less electronegative. Though both are oxygen and fluorine, both are electronegative. But when they face each other or encounter each other, which one you should consider as a negative charge? Okay, remember this Ponsel-Brissy. Got it? Ponsel-Brissy is the decreasing the mnemonic to remember the decreasing electronegativity order of various element form, fluorine, oxygen. Okay, and the first two elements, if they are present in the same molecule connected directly to each other, fluorine is the most electronegative element of the whole periodic table. Just you should remember it. Okay, got it?
Yeah.
So now tell me which one should be considered negative and which one should be considered positive. Should I consider F plus or F minus?
Yes. plus.
F plus. F is the most electronegative element. Okay.
Minus.
In the list also, F was placed first. On FON means fluorine was most electronegative. That has tendency to pull electrons, okay, from all the other element. So fluorine is -1. Got it?
Okay.
Is it clear? Think of it in this way. OF2,
Okay.
right? So fluorine is -1. Fluorine is -1. Okay. And overall charge is neutral. So if you are taking -1 on each one of them, what charge you should take on oxygen? +2. Got it?
Okay.
Similarly, what is the oxidation number? +1. Or you can take it as 2x but these are rare conditions. Only happen when oxygen and fluorine face each other. Normally, what you will take uh, oxidation number of oxygen, you will take it as -2 only in most of the compounds. Got it?
Okay.
Like in these cases. But if somebody gives you some exceptional conditions, then you should think about these exceptional conditions. Not under regular circumstances. Next is your oxidation number of hydrogen, though we already know it. Oxidation number of alkali metals. What are alkali metals? Alkali metals belong to group 1, the group which is on the extreme left hand side. Okay.
Sodium.
Yeah, lithium, sodium. Like rubidium, cesium, francium. Okay, they have just, if you look at their electrons, like sodium, it is having 11 electrons atomic number. So they have just one more electron uh, from the noble gas. Got it?
So what's RB and Cs?
Rubidium, cesium. So just one extra electron. They are actually just one ahead of a noble gas. And we have seen a abbreviated atomic number, like lithium is atomic number is 3, so helium and one extra electron. Sodium is 11th element, so neon, which is the 10th preceding noble gas, and 1 in 3s1. So they will lose one electron and they will always have +1 charge. Oxidation number of alkali metal is +1. Oxidation number of alkaline earth metals. That is group 2. What all elements fall in group 2? Beryllium, magnesium, calcium, strontium, barium, and radium. They will have plus, and they are metals, so electropositive, they will lose 2 electrons because they have 2 electrons more than the preceding noble gas. So when they try to form a cation, they will lose up to an extent so that they are left with noble gas. Okay. So for example, magnesium is the 12th element. So it will lose 2 electrons to acquire 10 electron to have 10 electrons finally in the di-positive cation, which resembles the electronic configuration of neon, 10 electrons. Okay. So oxidation, this is quite simple in any compound. If you come across alkali metal or alkaline earth metal, okay, you can take their oxidation number as +1 for alkali metal and +2 for alkaline earth metals. Got it? Is it clear to everyone?
Yes, sir.
Okay, great. Next is, what about hydrogen? Hydrogen is also a very important element, and it actually formed the basis of definition of reduction. Okay, so we should define the oxidation number of hydrogen also. Oxidation number of hydrogen. What it should be? What do you feel? Oxidation number of hydrogen is, first of all, it's quite common. I already said it is 0 in H2, which is its elemental form where it is not connected to any other element. Okay. It is +1 when hydrogen is connected to an electronegative element. Got it? Like HF, HCl we have already seen, H2S, H2O. What is the oxidation number of hydrogen? That is +1. This is +1 -1. Why? Because hydrogen is being connected. This is +1 2 times or -2. +1 2 times oxygen is -2. Because in all the cases, the hydrogen is connected to a non-metal. And these are more electronegative than hydrogen. So hydrogen will carry plus charge. Got it? So this is the most common condition. But there are some rare conditions also. In those rare conditions, oxidation number of hydrogen is -1. Okay. In metal hydrides, so we should not feel surprised when we try to write the formulas. Metal hydride, suppose sodium hydride. Okay. Calcium hydride. And means hydrogen is, in these cases, hydrogen was connected to non-metal. So non-metal was given negative charge. Non-metals are more electronegative. So hydrogen was having a positive charge. In this case, the hydrogen is connected to metal. That's why metal hydride. So metal is having a positive charge, that we know. Just now we have seen. Okay, metals are electropositive. You all.
H.
Pardon?
What about hydroxide?
Hydroxide, yes. Hydroxide OH minus. What is the oxidation number of H? +1. Because oxygen is linked to the hydrogen is linked to oxygen, which is more electronegative element. So everywhere it is, most of the cases it is +1. Only in the case of metal hydrides, in metal hydride the condition is reversed because metals are electropositive, so you should give negative charge to the hydrogen. Got it? Sodium hydride, calcium hydride, like that. Got it?
Yeah.
Yes.
So this I hope is clear to you. Okay, so what is the oxidation number of so let's use this to find the oxidation number. I will give you one question of where you have to find the oxidation number of nitrogen in the following compounds. Most common molecule is NH3, ammonia, N2, which is there in our atmosphere, N2 gas, nitrogen gas, salt of ammonia, ammonium chloride, oxides of nitrogen, if we consider N2O, NO, N2O3, NO2, N2O5. So what are the oxidation numbers of nitrogen? Let me add two more. These are very, very common compounds. NH3. Let the oxidation number of nitrogen be X. Right, Nabila? Maha.
Yes.
So what should be the oxidation number of nitrogen in ammonia?
So H3 will be, how do we write? X plus
Yeah, H is connected to
3 hydrogen.
H is plus one, okay, because it is connected to non-metal. So there are three plus one, plus one, plus one, plus one,
Ammonia
plus
equals -3.
-3. Got it. Yes, exactly. N2.
0.
0, it is elemental form, right? For nitrogen in ammonium chloride.
So the chlorine will be -1 now.
Yeah, chlorine will be -1 exactly. Because it is a salt, ammonium chloride and H4 plus and Cl minus, you can assume.
3. +3. Sorry, -3.
-3. Nabila, are you getting -3?
No, sorry.
X plus 4, because plus 1 4 times, minus 1 for Cl. Total charge, there is no total charge is given, that is 0, right?
Okay.
So X is minus 4 plus 1, if I take them on the other
Yes.
side, and this is
So for N2O, it's 1, positive 1.
yeah, oxygen is minus 2, and there are 2 nitrogen. So plus 2 is distributed on 2 nitrogen, each one should carry plus 2. Got it. Correct. NO.
For NO, it's positive 2.
Yes, oxygen is minus 2, so this is plus 2. Got it? Nabila, are you getting?
Yes, sir.
N2.
For N2O3, it's positive 3.
Yes, plus 3. 2x minus plus 3 times minus 2 equal to 0. X is
Yes.
plus. Okay.
For
Nitrogen
NO2,
di-
it's 4, positive.
yeah, plus 4. N2O5.
I got it, sir.
This we already did, plus 5. Sometimes it is very simple, like you might have did it in class 10 where you cross multiply with the charges, okay? Similarly, there are just 2 elements, you cross multiply with their oxidation numbers. Got it? So
Yes.
2 for oxygen, minus 2 for oxygen, and plus 5 for nitrogen. Like that. Cross multiplication. For 2 elements only you can do that. Otherwise, you can just use the method 2x equal to 2x equal
So for
to,
sodium, should we take positive 1?
yeah, sodium it is plus 1. Yes. So I told you that sodium, potassium, the alkali metal always plus 1. Alkaline metal always plus 2.
I'm getting a fraction. Minus 1 by
Yes,
2.
so plus 1, yes, exactly. Plus 1 is there on N8. So minus 1 is there on N3. So minus 1 distributed on 3 minus, so it is minus 1 by 2. So let it be x, okay. 3x plus 1 equal to 0. X is minus 1. Got it?
So how do we find for the next one?
This is also easy. Nitrogen is connected to hydrogen. There are 2 nitrogens. 2
So should we
nitrogens
take as N2H4?
N2H4. Yeah, this is hydrogen. So hydrogen, nitrogen, hydrogen is, because it is connected to electronegative atom. Hydrogen is plus 1. There are 2 nitrogen atom, right, Nabila? So
Yes, sir.
what should be the oxidation number of nitrogen?
Minus 2.
Yeah, minus 2. Okay, got it. 2x plus 4 equal to 0. This is the way in which we can do. 2x plus 4 equal to 0. X is minus 2. Right?
Yeah.
Yes, sir.
Next is what could be the value of maximum oxidation number of any element? Maximum doesn't mean that always you will have that positive oxidation number, but what is the possibility? How much it can go? Okay, in order to
Mhm.
gauge that, we need to know what are the total number of outer valence electrons. So if you try to figure out the total number of outer valence electron, the metal can lose that outer valence electron, and that is the maximum positive, only the valence one, not the all of them. Got it? Because once you remove the valence electron, you are left with a noble gas core. Got it? Noble gas core means the inner electron which are equivalent to noble gas. Got it? So
Yeah.
from that, it is very difficult to remove the electron. Once you have the noble gas configuration, that's it. Okay. You should stop removal of electrons. So maximum positive charge or the maximum oxidation number, positive oxidation number, which an element can have will be equal to its total number of valence electron which can be removed from its outermost shells. Okay. Is it clear?
Yes, sir.
Yeah.
So we have seen the electronic configuration of manganese and chromium. Chromium was the 24th element. Manganese was 25th element, right?
Yes, sir.
24th, I told you the trick.
Equally.
Write the preceding noble gas, okay? Argon, which is the 18th. I also asked you to remember all the atomic numbers of the noble gases, okay? Because they act like a landmark, right? And they will help you to clearly get the idea where your atomic number is, okay? So 24, the preceding noble gases are argon. 24, I told you 2 and 4, okay? That was the trick. So 4s2 is filled first because N plus L was lower, 4, and 3D was filled with 4 electrons, 4 and 2. Okay, but there was an exception to it. What was the exception?
It can be stable on all
Hmm.
sides.
Yeah, that one electron jumped actually 4s, one electron moved to 3D. Okay, but that will not affect this oxidation number. Just I'm trying to recall the electronic configuration. It has become 3d5 and 4s1. And the reason I gave you was the extra stability of half-filled d substance, d orbitals, because they tend to exchange their positions and that's why they become more stable. Got it?
Yeah.
So suppose if I ask you, in all the compounds of chromium, potassium chromate, dichromate, Cr2, 3, okay, a lot of compounds are there. What could be the maximum oxidation number? Without looking at the compound, just by looking at the electronic configuration, can you try to predict what could be the maximum oxidation number of chromium? How many maximum oxidation number? You need to remove the electrons, outer electrons. So how many outer electrons you can remove? Maximum. You should remove up to that many electron so that you are left with only the noble gas core. Got it. So maximum you can remove how many electrons? 6. Got it?
Yes, sir.
So what could be the maximum positive oxidation state? Is it clear? In the same way, I'm going to write the electronic configuration of manganese, where there was no exception. Argon, the preceding noble gas, and 25 means 2 and 5, 4s2 and 3d5, right? Maximum, if I want to consider the maximum positive oxidation state, that is, I can remove the outermost electron, all the outer electron can be removed. Beyond that, it will be impossible for me to remove the electrons from argon because that is a noble gas that is very stable. So the maximum positive oxidation state will be +7 because you have 7 outermost electrons. Got it? For Na group 1, there was just only 1 outermost electron. Okay. So that can only be removed 1. No more options were there available for you to remove electron. But in manganese, you have different, you can remove 2 electrons also. Okay, because it is a transition metal. So transition metals have multiple electrons, many electrons are there. So they can exhibit various oxidation states. Got it? That we will be studying in class 12 in DNA block elements also. And that this is the reason. Got it? So it is not that every time the manganese is +7. The maximum will be plus. Got it? Is it clear
Yes,
or
sir.
not? So manganese. And what could be the lowest oxidation, lowest negative oxidation? Normally, if we are talking about the negative oxidation number, we should talk about the non-metals. Because non-metals only have tendency to accept electron and become a negative charge. Got it? Fine. So, how many maximum electrons they can accept, that will tell you their the lowest negative charge which they can attain. For example, for the case of halogens, F, Cl, Br, I. If I ask you to give them electron, their valence electrons are 7. You can maximum give them 1 electron. Got it? Normally, we give electrons or take electrons up to extents so that they become noble gas. Okay. Once they attain the noble gas configuration, we stop. So fluorine is having 7 electrons in the outermost shell. How many more can you feed? 1 only. Because after that it will have 8 electrons in its outer shell, which is complete. Got it? So what is the lowest negative oxidation state for halogens? It is -1, -1, -1, -1. Got it? Is it
Yes.
clear or not? What is the lowest oxidation number for the oxygen? -2, -2, right? Right. What is the lowest oxidation number for nitrogen? Just tell me. Nitrogen, what is the maximum positive and maximum lowest negative? Both you can tell me. Maximum positive and lowest negative. I will help you out. I will write the electronic configuration. Nitrogen is the 7th element. 1s2, 2s2,
Hydrogens will be there. Sorry,
2p,
helium.
yeah, 2p3. So if you are looking for the positive oxidation state, you should remove the electrons. Okay. So what could be the maximum positive oxidation? How many should you remove? You should remove all the electrons maximum for consider maximum. You can remove all the electrons from the outermost shell.
So I don't understand.
Maximum positive. How you will get that? By removing or by adding electrons? Positive charge. Electrons are negatively charged. If you remove them one by one, you will have a positive oxidation state. Got it?
Yes.
Okay.
So what is the maximum number of electrons which can be removed? What is the maximum positive oxidation oxidation state which the nitrogen can have in its compounds? Okay, both are interrelated. So how many outer electrons are there which can be removed or which can participate in bonding? 5. Got it? Is it clear or not?
So for the lowest, it
You
will be
have
3.
this. I'm talking about the highest positive.
Okay.
Is it clear? So 5 you can remove. So that it will have maximum positive oxidation state as plus 1. But when I'm talking about the lowest negative oxidation state, you need to put more electrons to nitrogen. So how many more electrons can be put into nitrogen?
2.
How many more electrons can be fed to this nitrogen atom? You know that from your class, junior class. How many? You will. This is the valence electron. How many valence electrons are there? 5. Got it.
Yeah.
Valence there are. So how many more can you feed it?
3.
3 more can be fed. Right. So it will have that 8 octet complete. Okay. So lowest is -3. Got it?
Yes.
So look here. So we have already discussed, but we have -3 was there, 0 was there, +1 was there, +2, +3, +4, +5. Is it clear or not?
Yes, sir.
Yeah.
Okay. Lowest you can go only up to -3, but maximum you can put 3 electrons. Okay, and if you want to have the positive charge, that positive oxidation state, you can have +5 because there are 5 outermost electrons. That you can do. So each element has its capability of having the maximum or the lowest oxidation state. So there are problems when you have multiple elements, okay, multiple electrons, valence electrons. There you have a lot of options available, but you do not have options available on sodium. Sodium can just lose 1 electron, that's it. But manganese, you have a lot of options. Manganese, you can remove 2 electron, Mn2, MnO, MnO2. Okay, a lot of oxidation states are there for Mn. But I talked only about this maximum. Okay, MnO can be there, Mn2O3 is there, MnO2 is there, Mn2O7 is there, right? So without knowing the compounds, we found out what will be the maximum. +7. This is there, +7. This is +4. Okay, this is +3. This is +2. But maximum can be predicted by letting all the valence electron to be removed. Got it?
Yeah.
Yes, sir.
Okay. And for non-metals can have negative oxidation states where you can try to put more electrons to them. But how many more electrons? That many electrons so that they will have